Hello everyone. In this lesson, we will talk about normal line. A line which is normal to a curve at a given point is a line perpendicular to the tangent at that given point. So before we talk about the normal, we have to talk about the tangent. Because in order for us to find the equation for the normal line, we will have to find the slope for the tangent line first. So perhaps it's a good idea that I go back to our previous lesson and review a little bit for everyone. So in previous lesson, we were talking about a line tangent to a curve. Okay, so in finding the equation of a line tangent to a curve, we need to differentiate the function with respect to x. Then, if the values of x is given to us, we will substitute that value of x into the differential equation to figure out dy over dx. Then dy over dx is the slope of the line tangent to the curve at that given point. So that is the whole thing behind the idea of finding derivative of a function. Then, after we have a slope, we can substitute into this point slope form equation to find the equation for this tangent line at that given point. And then we have to write it in general form. Okay, so we did two examples in this lesson. Then we kind of stop there, and then in this lesson we talk about the normal line. And before I continue on, I would like to remind everyone that I have quite a few examples to work with for this lesson. I will have 4 examples. So I will work with 2 examples in this video, and I will do the last 2 examples in the next video. So there are 3 videos for the application of derivative regarding tangent and normal lines. Alright, so let's get back to this. Okay. In previous lesson, I gave everyone the step to follow. Basically, I expand this from there, because before we can find the normal, we have to talk about the tangent first. So if you find derivative of that function with respect to x, and you substitute the value of x into this differential equation, you find dy over dx. It means that you are finding the slope of the line tangent to the curve or to the function at that given point. After you find the slope of the line tangent to the curve, you will take negative reciprocal of that slope to find the line perpendicular to that. And the line perpendicular to that tangent is actually called the normal line. Okay, so we cannot skip the step of finding the tangent. Without the tangent, we won't have the normal. Okay, so just keep that in mind. And I mentioned to everyone here, if the 2 lines are perpendicular to each other, their slopes are actually negative reciprocal of one and the other. And then we still find the equation of the straight line of this normal line by applying this point slope form. And make sure that the slope that you are using here is a slope for that normal line. Okay, so let me find let me write down the equation for the 2 tangent and the normal lines, expressing the negative reciprocal of one and the other. Okay, so just want to emphasize the notation for everyone. So if I write this notation, I hope everyone familiar with that. So if I write empty, that means the slope of the tangent line. So I will write -1 over mn. Okay, so this representing negative reciprocal of one and the other, because you have the tangent line, and a line perpendicular to that tangent is called the normal. The specific terminology for these 2. If 2 lines are perpendicular to each other, one is a tangent, then the other one is a normal. Okay, so for this equation, I can also write it as slope of the normal lines is also equal to negative reciprocal of the slope of the line tangent to the curve. And let's talk about this example here. Find the equation of a line in general form. So in general form, it means that we need to have ax plus by plus c equal to 0, where a, b, c's are integers. Okay, and this one we need to have it normal to the curve. Y equal to 4 divided by 5 minus 2x, all of it in a bracket square. Okay, so let's examine the point x equal to 2 at this point. So right here, if I don't have the value for y right now, but I just set x equal to 2. So right here, I come up to this. I saw the 2 is representing the line tangent to this curve. Okay, to this function at this point. And then this line right here is more like a normal line. To scale it off a bit, but it's just representing the function on this graph, and then the 2 line to show you that how it actually works. Okay, the line normal to the curve is the one that perpendicular to the tangent at that given point. Okay, so let's differentiate, and then we start from here. Okay, so the equation given to us as this. So what I will do is I will write it as y equal to 4 times 5 minus 2x, all of it to the exponent negative 2. Okay, so before you differentiate, you analyze this a little bit. So that you have 4 divided by this binomial raised to exponent 2. Do you need to use a quotient rule? No, you don't have to, because you don't have a variable x as a numerator. Okay, so for this, you can just simply convert this into the exponent, and then you can just apply the chain rule. So that means you raise a function to a power, and then you can just differentiate using that formulas. So I can write that formulas for everyone. So if you have derivative of u raised to exponent n as a function of x, okay, so that n un minus 1, and then you also have to multiply by du over dx. Okay, so this is the chain rule that I'm talking about. So in this case, I will write dy over dx. Okay, dy over dx will be your slope, right? So 4 times negative 2 will give me a negative 8, but I will write 4. I will write it down for everyone. 5 minus 2x, negative 2, and I minus 1 for that. Now I have to multiply by du over dx. Derivative of 1 inside the bracket, derivative of 5 is 0. Derivative of negative 2x will give me negative 2. Okay, at this point, you see that dy over dx is equal to, you will have 4 times negative 2 times negative 2 will give me 16. And I raise this exponent to the negative 3. Alright, so first of all, we are checking if we are doing the differentiation correctly, because we don't want to end up with a wrong derivatives, wrong answer, and then it will carry on to make a wrong slope, and then all the work that we put in to find the equation will be affected by that as well. Alright, okay, so the next step is x is given to me as 2. So what you want to do now is when x equal to 2, you are going to substitute x equal to 2 into this equation to find dy over dx, because dy over dx is the slope. Okay, so here's the notation that I emphasize to everyone. So dy over dx, x equal to 2. So this is how I evaluate this in terms of x equal to 2. Okay, so then at the same time, I would like to write my equation as 16 over 5 minus 2x, all of it raised to exponent 3. So it's easier this way, right? So I have 16, 5 minus 2 times 2, okay, raised to exponent 3. So I will have 16 divided by 1 to the exponent 3. So in this case, I just have 16. Okay, so mt equal to 16. You may want to label that right away, because you don't want to forget that you are going to find the equation of the line normal to the curve is not the one tangent to the curve. So from here, you can see that mn is equal to negative 1 divided by 16. Okay, like the negative reciprocal of the line tangent to this curve. Okay, so here we already have a slope. So if we talk about finding the equation of a line, a straight line, we need to have y minus y1 equal to m x minus x1. So this is the point slope form of the equation to figure out the equation of a straight line. And if you use this, you need to have the coordinate x1 and y1. Okay, and the question only give you x equal to 2. So in order for you to have y, the corresponding value which I want to show everyone according to this graph here, when x equal to 2, we need to find the value for y. Then all you do is just take x equal to 2, substitute into this original equation to find the value for y. Okay, so to find y, given x equal to 2, then what I need to do is I will have y at x equal to 2 will be 4 divided by 5 minus 2 times 2. Okay, all of this is raised to exponent 2. So I will have 4 over, so 5 minus 4 is 1, 1 squared is just 1. So I should have equal to 2 as y. So then the coordinate that I'm talking about is 2 and 4. Okay, so having 2 and 4, what you do next is you are going to substitute that into the equation. So I will have y minus 4 equal to negative 1 over 16 and x subtract 2. Alright, okay. So now we just have to use algebra, our knowledge in algebra, in order to convert this equation to an equation in general form. So I suggest to everyone that you get rid of this 16 right away by multiplying 16 over to the other side of the equation, and make sure that you multiply by y minus 4. So 16 times y minus 4 equal to negative 1 times x minus 2. So what I have is I will have 16y subtract 64 equal to minus x plus 2. Alright, okay. Then all you have to do now is just bring all of this over to this side of the equation and let the other side equal to 0. So I will have x plus 16y subtract 64 subtract 2 equal to 0. Okay, so in this case I will have x plus 16y subtract 66 equal to 0, and this is the equation in general form. So in general form, so this is the equation for the line normal to the curve. At x equal to 2. Okay, so now you see that you are having a, b, c as integer. So a equal to 1 in this case, b equal to 16 in this case, and c is equal to negative 66. Okay, so having this equation as a x plus by plus c equal to 0, the a, b, c must be as integer. And then I indicate those integers here for everyone. Alright, so let's move on to the next example. Okay, so the next example is a little bit more challenging because it's saying that I find the equation of the line in general form tangent to the parabola y equal to x squared minus 3x plus 2 and perpendicular to this line. Okay, so let's compare example 4 with the example that I have up here. The example I have up here is I'm giving you a value for x, okay? And then you differentiate. We always have to differentiate the function, of course. And then we substitute the value of x in to find the slope. So after you have the slope, you figure out whether you have to find the line tangent to the curve or normal to the curve. Then you have to apply the negative reciprocal here in order to excuse me, yeah. So you have to apply these formulas here, like the negative reciprocal, to find the correct slope, and then you substitute into this point slope form equation to figure out the equation either for the normal or the tangent. So this is a straightforward application question. They give you the point and the function, then you just have to differentiate and get that point to figure out the slope. But for this example here, what they ask you to do is they are asking you to, they don't give us the point, they ask us to find the line tangent to the parabola. So this is the parabola. You know, this is the function that you have to differentiate, right? So a line in general tangent to the parabola, that means you have to differentiate this equation here. And then differentiate this, you find dy over dx. But where is the point x for you to figure out the slope? Alright, so, but then the key to find that is in here. So this tangent to the parabola, this tangent line, is perpendicular to this line. It's perpendicular to this line. So the key is perpendicular in this case. So in this line here, you can pull the slope out from this line. Okay, so we will get to that in a minute. I just want to explain to everyone how to analyze your problems before you can figure out the step how to work with it. I often mention to the student that before you want to solve a certain word problems or anything involving calculus, the best is to analyze. Okay, to analyze to see what we understand about derivative, what do we do with derivative, why do we find derivative. When we find derivative of a function, we target finding the slope of the line tangent to the curve at a certain point. If the point is not given to us, or the point is not there, then we can just have the general form, the differential equation dy over dx. But if a point is given to us, we can substitute into that dy over dx equation to solve for the slope. Okay, having the slope, having the point, they ask us to find the equation of the tangent line. So if we understand that completely, then if we have to expand into a little bit more of not giving the point, but then we can find the slope out from here. Okay, so anyway, I draw the graph here for everyone. I draw the graph of the y equal to x squared minus 3x plus 2. So this is the parabola. Opens up. Okay, and then this is the tangent. You can see that this is the line tangent, because this line here is the line tangent to a curve is the one that touches the curve at only one given point. So you see, this one has to be the green line that I just highlight to everyone has to be the tangent line, because it touches this parabola at only one point. And what is this line here? It cuts the parabola at 2 points. So this definitely not your tangent line. This line is just a line, but it's perpendicular to this tangent line. But it's not a normal, okay? It's not a normal. A normal is when it's perpendicular to the tangent line at that given point, in the line at the point that the tangent touches the curve. So this line is just any line at all. It's just a line perpendicular to this to this straight line, okay, to this tangent line. Okay, so as you know, the very first thing we do is we have to differentiate. And you know which equation to choose to differentiate, because you need to differentiate the function that is given to you, which is the parabola. So I will write y equal to x squared minus 3x plus 2. Okay, then I figure out dy over dx, which is 2x minus 3. Okay, so I found this, and then how do I find the slope? Okay, how do I find? Okay, so the key is here. Okay, perpendicular to. So the question said key is perpendicular to this line right here. So let me label this line. This line is the 5x minus 2y minus 10 equal to 0. And you see, if this line is perpendicular to this, you can use that concept related to the slope. You will use this equation to figure out the slope of this perpendicular line. And because of perpendicular, finding the slope of this line, you can use a negative reciprocal to figure out the slope of the line perpendicular to it, right? So then, after finding the slope of this line, you will take negative reciprocal of that. It will be equal to the slope of this tangent. So what is the slope of this tangent? It's the dy over dx. So from here, you can at least solve for the dy and the dx, right? Okay, so let's do that. I am going to rewrite my equation for that perpendicular line. Okay, excuse me. I will write 5x I'm sorry, this is okay. 5x minus 2y minus 10 equal to 0. Okay, so what you want to do is you can pull the slope out from this equation. So I will target the equation called the slope and intercept form. So y equal to mx plus b. Alright, so if I somehow convert this into this form, I can pull out the slope right from here. Because if you have an equation equal to y equal to mx plus b, make sure the coefficient in front of y is 1. Then, if any equation fitted this form, then the coefficient in front of x will be your slope, and the value after is the y-intercept. So that means I will solve for y. Okay, so that means I will solve for y. Okay, from this equation. So I will make this equation star. So then, in solving for y, I will have negative 2y equal to negative 5x plus 10. Okay, but I need to have the coefficient here as 1. So I need to divide everything by minus 2. Okay, so we make sure that we do this correctly. And what you see is there's cancel, and I end up with just y on the side, and negative 5, excuse me, sorry everyone, this one keeps zooming out, and I think because my hand touches the screen, but I can try not to touch the screen. Alright, so 5x divided by minus 2, you can see that this negative cancel out, and I want to write it like this, 5 over 2x. Okay, and then this one is negative 5. So this 5 over 2x, the coefficient in front of this term will be m. Okay, m of the line perpendicular to the tangent, right? Okay, so this is the m of the line perpendicular to the tangent, the slope. Then, therefore, the slope of the tangent is, so I will take -1 divided by this 5 over 2. Okay, so here I will put m of t. So I just want to write this down for everyone in this form, so everyone realize that you divide it by a fraction, then you multiply by the negative of the, inverse of the next fraction. I'm sorry. Okay, I'm writing and reading at the same time. So therefore I set negative when I write a -1. Excuse me. Okay, so -1 divided by 5 over 2, it means that you multiply by the reciprocal of this function. So you invert and multiply because you divide it by a fraction. So in this case, your mt will be equal to -2 over 5. Okay, so having mt equal to -2 over 5, then what do we do next? Okay, so go back here. We are finding the derivative as this equation, right? Okay, so let me rewrite that for everyone. Okay, so I'm finding dy over dx is equal to 2x minus 3. And from the line perpendicular to this slope, I end up with this mt equal to -2 over 5. This, in fact, equal to my dy over dx. So in writing the equation of a straight line, you need to have a point and a slope. So you found the slope, but what about the point? It means I am going to substitute -2 over 5 into this equation so that I can solve for x. Okay, so here I can solve for x. Alright, to solve for x, I will have it equal to, I am going to bring -2 over 5. I will make that into a plus 3. So here's 2x. Okay, so from this 2, I should have it equal to, let me see if I have more space. Yes, I do. I do have a lot of space. So I should have this equal to, okay, so this should be 15 over 5 equal to 2x. So I have positive 13 over 5 equal to 2x. So then I should have 13 over 5 divided by 2 will be equal to x. Therefore, I should have 13 divided 5 divided by 2 equal to x. So x equal to 13 over 5 times 1 over 2. So x is equal to 13 over 10. Okay, so 13 over 10. Having x equal to 13 over 10, I will substitute. Okay, substitute x equal to 13 over 10 into the original equation. The original y equal to x squared minus 3x plus 2 to find y. Okay, because you need to have a point. So therefore, I am having y evaluate at 13 over 10 will be 13 over 10 squared minus 3 times 13 over 10 plus 2. So if you do this calculation, which I will leave it for everyone to figure out, but I think I might as well do that. Okay, so I might as well do this for everyone. Okay, so y evaluate at 13 over 10 will be equal to, so I square this, I should have 169 over 100. I subtract 3 times 13. I should have 39 over 10 plus 2